Good morning, everybody. Welcome to Cirrus Research webinar. I hope you can hear me. Just a couple of things before we get going. This session lasts about an hour and a half. We've got about an hour of the presentation this morning, and then we should have about 30 minutes or so at the end for questions. I know some of you will just be joining. For those of you that have been before, welcome. For those of you that are new to Cirrus Research and these webinars, welcome to you too. Very good to have you all here. Somebody's just commented that they can't hear me, which is always a relief when we start these presentations in these webinars. So what are we doing today? This webinar is about noise monitoring in the workplace. We've got a title of Sound Decisions. So I'm going to take you through quite a few things, but first of all, let me explain a little bit about who I am. My name is Craig Story. I've been with Cirrus Research for about 13 years. I'm a business development manager in the UK. I also get involved in sort of large projects. I do noise at work, environmental noise, all sorts of different things to do with our noise measurement products. So hopefully I'll be able to answer any of your questions that you put through. So if you do have any questions, please just put them in the chat, and then when I finish this, the formal part of the presentation, I'll have a look through them and go and answer as many as I possibly can. So I hope you enjoy it, and let's just make a start. So sound decisions. So what are we going to cover today? We're going to focus on occupational noise assessments, which is one of the key things that you will have to do if you're looking at potential noise issues in your company. But we're going to do a few things. We're going to look and understand what are the occupational noise hazards that occur in different organizations. We're going to have a look in some detail, and this is UK focused, but it does apply in most territories, the regulations and legal requirements for businesses to protect their employees. We're going to spend quite a bit of time on how to monitor noise levels effectively to make sure that you're actually getting a really good sample and a really good view of what the potential risk is for your employees. We're going to look at the tools that you can use to actually do this type of measurement to get the data so you can make the right decisions. And then we're going to look at interpreting the data a little bit. So you can say, well, what does that mean? You've got a number. What does the number mean? And how can I take that forward? And then looking at implementing some controls and how to actually protect your workers. What are the right things to do? What are the wrong things to focus on? And then we'll have a Q&A session at the end. So it's quite a bit to cover. I've selected some slides and I'll talk around them quite a bit. But hopefully you'll find this interesting, and please ask as many questions as you like. And as I say, hopefully I'll be able to get through as many of those as possible at the end of the session. So the first question I always ask, and I ask of people that I'm training, is you've got to think about this. Why is noise measurement required at all? Because if you think about it, noise is one of those invisible things that can affect us as human beings. So we can see clouds of smoke. We can sense heat, humidity, other types of danger. Falling from height, whatever it happens to be. There's a visual element to it. And one of the things about noise is it is invisible, and the way we pick up noise or sound is obviously through our hearing. So I've got a bit of a picture there of our very complicated hearing system, which I'm sure you'll have seen before. So we need to understand the risks associated with excess noise. And it's because we're trying to protect our workers from a few different things associated with too much noise in the workplace. And the most obvious one, and the one that everybody knows about, is preventing noise-induced hearing loss. So this is where if you expose people to too much noise, too much sound over a long period of time, and there's been lots of work and papers, and lots of organizations have looked at this over decades and decades. If you expose people above a certain level of sound and above a certain level of decibels over a prolonged period of time, you will get noise-induced hearing loss. That's what will happen. So we need to protect our workforce against that. And one of the things about noise, yes, it's invisible, but you don't really know that it's affecting you. So you can go to work, go home, work home for many, many days, weeks, months, even years. And if you are exposed to too much noise in the workplace, then you will not notice the effects that it's having on your hearing, because the changes are usually slow. They take place over a long period of time. And it's only maybe even decades later when you start to worry that you're turning the TV up too loud, you can't hear your partner speak properly, you're asking everybody to repeat themselves, etc., etc. So it's insidious. So that's what happens. So it's not something that has an obvious cause and effect. Not like if you were trying to cut open a cardboard box, you didn't have the right gloves on, you weren't using the right knife, and you cut your finger. There's an immediate cause and effect. You don't get that with noise. And that means it's more difficult to manage this as an issue with your workforce, because they're not seeing that immediate cause and effect. There is one caveat to that, I must say, is that you can be affected by high levels of noise almost immediately. So there is a position where if you've got super high noise levels, even if they happen over a relatively short period of time, an example would be hitting a very large piece of metal onto another piece of metal, you're going to get a huge sound wave hitting you, and it's almost instantaneously. It lasts maybe less than a second. That could potentially, if it's loud enough, if there's enough decibels, if there's enough pressure there, that can damage your hearing instantaneously. And that's where you get things like a burst eardrum, which people have heard of. So that's the exception. Excuse me. That is very rare. That is not something that would occur normally. It's not something that is a usual occurrence, but it is something that we need to understand that may happen in the workplace. And we'll come on to that in a bit later on. So we need to understand what the hazards are of too much noise, both the long and the short term of it, types of noise in terms of high noise levels. And of course, we need to have some understanding of what that level is to see if our people are at risk or not. And the other side of this is, I've just put another one there, which is reducing stress. So you can get levels of noise in the workplace that maybe aren't at the, if you like, inverted commas, dangerous level, but can induce stress. So it's just something else to think about. So you've got some very annoying sounds that might be happening that, in terms of your hearing, it's not going to affect it, but it could affect people's comfort in their workplace as well. And of course, on the flip side of this, you've all heard about people suffering from environmental noise. And this is generally at a much lower level in your home, etc. And that does cause stress. People can have sort of heart problems, other problems that stress can cause. And again, that could still happen in the workplace. So it's not just about the absolute levels, it's maybe the quality of the sound as well. I'm not going to go too much into that, but just to let you know that's a thing out there as well. Okay, so we have an understanding of why noise levels need to be measured. So just one quick example here, just a quick slide. One of the things that can happen, not just noise-induced hearing loss, which is generally where certain frequencies of sound are very difficult to hear. You might not hear the higher frequencies so much, but it could also impact you in other ways. There are other medical conditions associated with your hearing that too much exposure to noise can cause. One of them is tinnitus. It's just a table here of the prevalence of tinnitus in various professions. Just to give you an idea that sometimes the percentage, if people aren't protected and you don't do anything about it, those percentages can get quite high. Okay, so let's move on a little bit. One of the things I wanted to talk about was the control of noise at work regulations. And this applies in the UK, but it is based on a European Union directive from way back in 2003. So basically, even though the UK has left the EU, Brexit and all of that, we're still bound by the set of regulations which came out in 2005, which basically means the whole of Europe are on a very, very similar framework in terms of what we can expose people to in the workplace. It replaced a set of regulations from 1989. They were just called the Noise at Work regulations. And the new one that came out, even though it's 20 years old this year, had a couple of changes which are quite major. The first of which is the title. It's called the Control of Noise at Work regulations, and that gives you a bit of a clue as to the way this legislation, this regulation is going. It's all about controlling noise at work, whereas the original one was a lot about measuring what the noise levels are at work and then protecting people. This is all about controlling noise at work. So the emphasis has changed. We will talk about this shortly, but it's a different emphasis in that you cannot just rely on hearing protection to protect your workers. You need to do more. And one of the other big changes in this set of regulations, as I said, they are 20 years old, is that there is the levels at which you can expose people to, which we're going to cover in a second, have been dramatically reduced. Those of you that know anything about decibels, those limits were basically reduced by about 5 decibels, and that's a lot. That's more than a halving of the amount of sound energy that we're allowing people to suffer at work before we actually do anything. So those levels came down by 5 dB. So that's a lot. This has requirements, specific requirements, obviously on employers and also employees. And it all comes under the auspices of the Health and Safety at Work Act 1974. But this is specifically used for people who are employed. So it doesn't rely or doesn't apply to members of the public who may be exposed to high noise levels wherever they are, concerts or whatever else. This regulation doesn't actually apply to them. So it's really just employees. Okay, so what is it? So the idea of the regulations is to make sure that, in a first instance, you eliminate completely or prevent exposure to noise at its source. That's the goal. That's the gold standard, really. If you've got employees in a workplace that are exposed to high levels of noise, you need to be getting rid of that noise, whatever's causing it. That's the aim. That's where you're aiming for. Like all health and safety practices, there is a specific hierarchy of controls around this, which I will cover in a separate slide. But what you have to do as an employer is make sure that the first thing you do is assess the risks to your employees from noise at work. And then again, we're going to look at that. So when you're assessing the risks, you need to know which employees are potentially at risk or actually are at risk from high levels of noise in the workplace, the people that you're responsible for. Once you've found that you have some people that are potentially or actually at risk from those high noise levels, you need to take some action to reduce that exposure that has produced those risks. That's the key thing you need to do. You need to take some action. You can't just leave it. And what you really have to do is to look at all options in trying to reduce that risk, in getting rid of the noise, whatever it happens to be. And then only if you can't lower the noise levels by any other means, it's only at that point that you're relying on providing hearing protection to actually mitigate that risk. Now, that's not to say you wait a period of time to try all of these things, switching machines out, turning things off, moving things around, whatever it is. It doesn't mean to say you wait until you've tried all that and then obviously rely on hearing protection. You're going to need hearing protection from the word go, obviously, because things do take time. You need to make sure, obviously, that you keep your employees involved with this. you need to make sure they've got the right sort of information, instructions, training, whatever it happens to be. So they need to be as involved with this as you are, because if they're not, then managing this going forward is going to be very, very difficult. So you need to make sure that you bring them along right from the beginning. And one of the other things, there's a bit more than this, but one of the other things I wanted to highlight was that if you find that there is a potential risk to health, so some of those workers are actually at risk, then you need to carry out health surveillance. And that's basically audiometry to make sure that you're keeping an eye on how their hearing is progressing. Now, all of this sounds okay. It's not an easy thing to do. You know that people will have noisy hobbies, whether it's going to rock concerts every night, or it's doing, maybe they're using a lot of power tools, whatever it happens to be. But, what you can be responsible for is your employees at work. Once you've given them the information and the knowledge of, and the training, etc., around this topic, it may very well help them in their private life as well, to make sure that they're not putting themselves at risk when they're outside of your control. So those are the basics of the Noise at Work regulations. So let's have a look at some of these exposure values. So what they've done is they've given you 3 levels at which you need to be aware. And the 3 levels are lower exposure action values, upper exposure action values, and then we've got some limit values. I haven't put the limit values on here, but I just wanted to focus on these 2. And the next slide after this maybe simplifies it a little bit further. So what we're interested in is 2 things. If you remember earlier that I mentioned that exposure to people over the long term creates noise-induced hearing loss, amongst other things. And also exposure to high noise levels can cause virtually immediate issues with people's hearing at the same time. So therefore, in the regulations, we need to look at 2 separate things. We need to look at an exposure over a period of time that we can measure. And we also need to look at what the highest noise level is that somebody's exposed to in any working day. And we call these things a daily LEPD, or personal exposure level. You can use weekly. So we've got a daily personal exposure level here, and the lower level of that is 80 decibels, A weighted. The purpose of this talk today, by the way, is not to really go into what's A weighting and C weighting and things like this, but there's a lot of information out there. If you have a look on the Cirrus Research website, you'll see a lot of information about what all these different terms mean. We've got a great sort of glossary of terms and things like that. I'll talk about it a little bit as much as I can. And also when, if you want further information, you can always contact Cirrus Research and we can answer any of your questions. So we've got this daily level of 80 decibels, and basically that's the average level over a standard working day of 8 hours. Now, if somebody works less than 8 hours, theoretically you can expose them to a little bit more, and when the calculation is done back to 8 hours, we're still looking at this 80 decibel level. And again, if somebody works more than 8 hours, you really need to be exposing them to a little bit less noise, because we're squeezing all of the noise they've worked in their whole shift into an 8-hour period to come up with a daily personal exposure level. So the low level is 80, and then we've also got something called a peak sound pressure level, and that's the highest level of sound or noise that somebody's exposed to in the day. And if you look at those 2 numbers, the first one is 80 decibels on average over 8 hours, and then the peak level is 135. That's way higher. So as long as a person, once you've done your work, has got a level and a daily average, if you like, of less than 80, and the peak doesn't reach 135, they're deemed to be not at risk. And similarly, we've got an upper exposure action value, and that is 85 for the average for the working day, and 137 as the peak, the highest level. So if I flip onto this next slide, this sort of tells you basically what that means. It sort of identifies it a bit better. So basically, if the 2 levels, the average for the day for the 8 hours is below 80 and the peak is below 135, they're not at risk. So typically you've got people in offices, they'll never reach those sort of levels. Yes, it doesn't mean to say that the noise level could reach above 80, but only for a relatively short period of time usually. And when you look at the average over this working day, that's when you can, you'll see that they're not at risk. So we've got this next level, which is the upper action level of 80 and 135. And then finally, we've got a limit value of 85 and 137. So between these two levels of 80 and 85 and 135 and 137 peak, there we've got people at risk. So these are the people that are potentially at risk. So their average for their working day is somewhere between 80 and 85, and their peak levels, between 135 and 137. So they're potentially at risk. Then the final one is if you measure, you've got your information, and they're above the 85 and 137 level, they are at risk, and they are a problem, and you need to do something about it. So there's lots of information and instruction and things. The very first slide I put up showed you the control of noise at work regulations. I would suggest if you can download a free PDF from the HSE website, or you can purchase a copy. It's a really good document. It's got lots of information in there, very well written, lots of sort of case study type things in there. So it tells you an awful lot. But really what we're trying to do with when we're measuring to understand whether people are at risk or not, we're first of all trying to see who is either potentially at risk or is actually at risk. And generally speaking, we're looking for these averages that we're going to measure. Is it above 80? And if it's above 85, then we know there's a problem, a real problem that needs to be situated. And then we also need to look at those peaks, 135 and 137. Now you could say, well, actually, if they've got a peak that high, 135 plus, isn't that going to make the average high anyway? So why have both? Well, actually, that's not the case necessarily. So you could have people with their general average noise level that they're exposed to once you've done the work is, below 80. But there could be just one instance or a couple of instances during their working day where you've got a really high noise level that's so high it breaches that peak level. But because it's so short and sharp, it doesn't affect the average so much. So you can have people with both. One example I always use is people sort of taking wheels off trucks with air wrenches, taking those big wheel nuts off. If there's a backdraft of air, their head is usually pretty close to the gun. That just one backdraft could be high enough. But if you do the measurements right and you look at their overall average for the day, it's probably okay. So these instances can occur. Okay, so there's a little bit about the numbers. So here's some typical noise levels. We've all seen this scale before. Typical offices, generally way below 80. Conversations at 60, these sort of things. So just to give you an idea of the sort of noise levels we're talking about. And I've not really talked about decibels too much in this, but just to give you an idea that when you go up by 10 decibels, the amount of noise energy that you're experiencing actually goes up by the power of 10. So a conversation at 60 compared to city traffic at, say, 70, the traffic is 10 times louder. If you've got a vacuum cleaner at 80 compared to the conversation at 60, it's now gone up by 10 and then another 10. It's 100 times louder, right? You don't appreciate it as being 100 times louder, but there's 100 times more energy there. If it goes up to 90 decibels, it's 1,000 times louder than 60. 100 decibels is 10,000 times louder than the 60 decibels of your conversation. So you need to be very well aware when you're talking about decibels that they go up logarithmically. So it goes up in basically powers of 10. So when you're comparing numbers, you need to be very careful with that. And what it means is where you've got high noise levels, 90 decibels plus, they have such a huge effect on people's exposure. Even though on the scale you can see, we like a 0 to 100 scale, don't we? When you can see that, it doesn't look that much louder. but it is proportionally so much louder, and it has such a big effect on people's exposure. So just be aware of that. Okay. So what should you do first? I went to an HSE presentation many years ago, and I was sat in a room, and we all had our sound level meters with us doing this sort of training. And they said, the first thing you can do, you don't even need to purchase any equipment. And I'm sat there thinking, well, you know, I work for an equipment manufacturer. This isn't good. But what they mean is that every business can do these very simple tests that I've got on the screen right away, just to see if they potentially have got a problem. Before you don't, you know, you can do a very quick, we call it a noise survey. There's no equipment needed. You can do what it says there, you know, if the noise is intrusive, but you can have a normal conversation at a meter distance between two people. Then, you know, if the noise is going to be like this for more than 6 hours, then potentially, you know, do a risk assessment, a noise assessment. You know, and then the extreme, then if you have to shout to talk to someone 1 meter away, you've got a problem, you know, you're going to need to do something. So it's a very quick test that any business can do without actually spending any money to see, right, well, are we okay? Well, probably are. Or no, we've got a problem. Let's actually look at this in a bit more detail. And that's the way we're getting to next. What is that detail all about in terms of the measurement of noise? What we need to do then, because we've had a quick look at the regulations, and we've had a look at these levels, these lower and upper action levels. We need to weigh then to get at these values. So we need to get hold of the exposure value. That's the average noise level that somebody's exposed to over an 8-hour working day, and the peak values. And we definitely need both. So any equipment that you use, assuming you've done that first test, to actually get some accurate measurements, is we need something, and it's a bit complicated, but we need an average noise level over a period of time. And we write this down as an LAEQ, and then T means how long you measured for. So it's got to be A-weighted. Now, A-weighted means, and this is all done in the equipment, whoever's equipment you purchase, A-weighted means we actually adjust it for what humans actually hear. Because you're sat in a room, you're listening to me, and you can hear noise, sound, etc., etc. But what you're hearing isn't exactly what's there. So human hearing is not perfect. We hear things in a certain way with the technicalities of our instrumentation within our head. So we adjust what's really there to what humans actually hear by using this weighting factor, A-weighting, and it's done in the equipment. And what we do is to get our daily personal exposure, the LEPD, we need it potentially to be calculated from a set of different measurement values from the LEQ, and we'll look at the equipment next in order to do that. And then the other item that we need to focus on whether we're exposing people more than what the regulations say is our peak noise level. And that is a different weighting factor on the peak, and that's C-weighted. And one of the things you've got to be careful of is there's a lot of equipment out there which will have A weighting on it, and it'll be a relatively cheap piece of measurement equipment you can buy off you know, eBay or Amazon or wherever. And if it's cheap, it generally doesn't meet the regulation standard, because a lot of meters out there will not have a peak measurement on it. So we've got a peak sound pressure level that your meter equipment has to measure, and that's done with a C weighting. And that's because peak noise levels are really, really high. And one of the things about human hearing is the louder the sound gets, the more frequencies we can hear. The quieter it gets, we typically don't hear the lower frequencies of the sound very, very well. It's just the way our hearing's built. So we need to be able to measure these two basic things: an average noise level over a period of time, and then a peak level. And there are two main tools to do this. Obviously, I put a picture of the Cirrus's equipment, but lots of other equipment out there. One is a sound level meter, and one is a noise dosimeter. And we're going to have a look at the differences between the two types of equipment. So the sound level meter is usually a device with a screen on it you can see there. It'll have lots of numbers on it, and you can press start, you can press stop, and you can actually take a measurement. It's ideal for doing spot measurements. So you can carry this around with you in your palm of your hand, and you can measure places. So it's great for measuring where people and spaces are. So if somebody in that picture there, I'm not sure what that is, but somebody was working in that environment, you could measure in that area close to them and get an idea of what the noise level is in the space that they're working in. And what it does is when you start any of these pieces of equipment, it starts its measurement process. And then when you press stop, it will give you a few numbers. And one of those numbers is the average noise level, or typically termed the LAEQ. That's the, if you like, average in inverted commas sound level for that period of time that you've measured. And it will also calculate for you what was the highest noise level, what was the highest peak level during the period that you've measured. So it's for measurement of a noise over time, obviously, but it's great for measuring locations. So if you want to then say, well, okay, great, so I can measure this location, I can measure in another location. How do I then work out what somebody's exposure is over the 8-hour working day, the LEPD? So you're going to need a number of these measurements, and you're going to need a tool to actually calculate from these measurements what somebody's exposure level is. Now, there are a couple of ways of tackling the issue with noise at work, and one is to measure and follow absolutely every individual and work out what their individual exposure is. And the other way is to, and it may be a combination of these, is to measure every location and say this location's noisy, you know, let's make it a mandatory and protection zone. This location's fine, we don't need to do that. So you know if people do what they're told, no matter which area they're in, the noise level will be fine because of the precautions that you've asked people to take. So, but that's not always the case, because you sometimes have people sort of bringing tools out and using a tool which adds to the noise in that area and it pushes them over. So taking individual measurements of all circumstances with a sound level meter is quite a good idea. These meters need to be ideally an integrating meter, which means it does the averaging. And just remember, the averaging that we're talking about of these noise levels in decibels is a logarithmic average. But don't worry, you don't need to know the maths. The equipment does that. So sound level meter, great for spot measurements, measuring places, measuring the areas where people work. The other one is a noise dosimeter. And these are personal noise dosimeters. You can see on the picture there that somebody's wearing that dosimeter on their shoulder. Lots of different types on the market. The ones we use typically don't have any screens, any buttons. They're just a little blue light that flashes to tell you that it's working. We believe that way people ignore them and you get a sort of a more realistic reading. But they need to be quite tough because they're following people. They're attached to the clothing, on the shoulder, close to the ear, because what we all want is an idea of what our ears are actually detecting. So whether you're using the sound level meter or whether you're using a noise dosimeter, then that should be measured where people's heads are, close to their ears. The great thing about the noise dosimeters is they will sit with that individual all day long and just continuously measure the noise levels. They will measure the average noise level, they will measure the peak noise levels, and that will give you a full picture of that person's noise exposure during the day. Now, you could say, well, I'm going to put these on absolutely everybody, and yes, you could, of course, but generally speaking, will people pick out certain groups, individuals from groups of workers in different roles, different activities? So you don't need to physically do everybody. You can if you want to, but you don't necessarily need to do everybody, but you need to get that full picture of what people's exposure is. So these are ideal for mobile workers, because if you try to follow somebody around with a sound level meter close to their head, it doesn't, you know, you're soon going to annoy people, and it's not, to be honest, it's not very safe. Because these dosimeters are on somebody for many, many hours, the device will also calculate their daily personal exposure as well. So it will be calculated straight away. So that's another sort of benefit for using a noise dosimeter. They're very, very handy. So you've got basically two tools at your disposal. A couple of other things you need to consider. One is, does it meet the standards in the regulations, which is just what I've mentioned earlier. So it's a certain class of or type of meter that the sound level meter must meet, a certain standard there, international standard, and make sure if you're purchasing or getting any meter, it does meet those standards. And there's a specific standard for a noise dosimeter as well, which again, it has to meet. So which one's best? Well, the general rule of thumb is, I think, if you need to know the level, the sound level, the noise level of a particular task or a process or an area, a physical area, then a sound level meter is best for doing that. You could do, for example, a sweep of your whole factory straight away, and just work out, first of all, where the noise levels are bad. And just by putting that in different areas, taking a measurement in certain areas, then you'll have this sort of, if you like, a noise map of your business to see where the noise levels are. But using a noise dosimeter, if you want to find out the direct exposure in an employee, that's where the noise dosimeter is best. And where it's not safe to use a sound level meter, or it's impractical to do so, that's where a noise dosimeter comes in. So typically we get people with using both. So they'll have a bit of a kit with a sound level meter and a few dose badges, dosimeters, to actually basically take account of all scenarios. But there's nothing wrong with just having a sound level meter. There's nothing wrong with just having noise dosimeters. As long as you use them in the right way and you're covering everything, you can still get the information that you need. So how easy are they to use? Well, once they're set up and running, a noise dosimeter, you don't need to set up, there's no manual intervention. You just make sure it's still running and they can go and do their normal job. If they put it on the correct shoulder, then it shouldn't interfere in their job in any way. But what you do need to do is to make sure you understand what that person is physically doing and where they are. So you could follow that person around and just make a note of what they did, where they went, or get them to fill in a form or something, a little, not like, a bit like a timesheet, just to give you an idea, because a lot of the dosimeters will not only give you these end numbers, the average noise level and the peaks, but they'll also give you a trace. So you get a little graph and you can work out where the noisy parts of the day are. So their overall noise level might be high, but there might be an activity or something happened, let's say at 11 o'clock in the morning, that just went super high. And then you've got to ask the question, what were you doing at that time? Well, I was using this hammer drill. Okay, right. So that's the hammer drill, it just spikes, right, for 10, 15 minutes or something using that drill. So then you can make some decisions as to say, well, your overall average was okay, but apart from that, I want you to wear hearing protection, for example, when you use that drill. So you're going to get a lot more information. You'll be able to take this a lot further, a lot quicker, having that information about what they were doing, where they were when they were using those dosimeters. With sound level meters, of course, the noise level instantly because you're there, you've got it on the screen. The difficulty with the sound level meter, I should say, is making sure you measure for the right length of time. So you've got to be careful, because you could run into a room, look at the number on the screen, and then run out again. Now, that's obviously not going to give you the right sort of level for any particular location, because noise levels do vary. So you need to be measuring in a fixed location for long enough so that the average that you're looking at on the screen settles down and stops varying. And you need to make sure that there's any intermittent noises that come in. I don't know, a compressor kicks in every 10 minutes or every 15 minutes. Make sure you encompass those, slightly unusual or more systematic sounds. Then you're going to get a really good sample, a representative sample of the noise in that area. Also make sure that you're measuring at the right height. So with the sound level meter, it's got to be, I would say, at least 1.2 meters off the floor, around about head height, average head height if you can. That way you're not measuring noise levels where people's heads are not, because it's their ears that we're looking at here. So we need to measure at the right height. So those are some of the few of the basic things. So they are pretty simple to use, these equipment. So I've mentioned a couple of bits of information there. One is the A-weighted average noise level, the LEQ. One is the C-weighted peak noise level. There are a couple of other things that are useful. When you've done all your work and you're going to be looking at issuing some form of hearing protection, then you need to make sure that you can issue the right level of hearing protection for the noisy area that somebody's working in. And you need a little bit, ideally, you need a little bit more information than just the A-weighted average and the peak level. The C-weighted average, so this is the average noise level, but it's using a different weighting factor, can be used. There's a tool, the HSE website's got a great little tool for calculating, a spreadsheet for calculating hearing protection levels. And there's another thing called frequency bands or octave bands that are on the meter. That's a more accurate way of determining which hearing protection is best. So having that little bit of extra information on your equipment will help you determine the right level of hearing protection, or even comparing the hearing protection you've already got and seeing if it's good enough to use in a particular area. So you just need to be wary about that. And the last thing I'll mention, if I get out of the way a bit, some equipment has other information on there. So let's say you've borrowed a higher end sound level meter, for example. It'll have things like maximum levels, third octave bands, things called LNs, all sorts of other stuff. That is all generally around environmental noise. Just ignore all of those. There's only a limited number of numbers that you need to focus on for noise at work, and those ones at the bottom you don't need to worry about at all. One of the key things, though, is because typical sound level meters have many numbers with dB after them, make sure you pick the right ones, the right frequency weighting, the right numbers. So LAEQ, LC peak are the two main ones you need to focus on. Because if you pick, you could have a one that has an LZEQ. Wow, what's that? That's without any changes to the noise level, so it's measuring what's really there, not what we're hearing. If you make some decisions on the LZEQ, you could be spending money to fix things that don't need fixing. So just be careful about that. As I say, the glossary and further information you can find on our website. So you've got your equipment, and you've chosen which one you're going to use. It could be a sound level meter, it could be the dosimeter, it could be both. How do we ensure that equipment is accurate, so that the data that we measure is accurate? Well, obviously, one of the things is, as I've already mentioned, measuring in the right place, measuring for the right length of time. That's always good. But the equipment itself should have a calibration certificate with it. And the Controlled Noise at Work regulation states that this equipment, really, the maximum level between two independent calibrations of that equipment should be no more than 2 years. We recommend annual calibration. That's your certificate. So it's like your MOT on your car. But what they also recommend, and this is standard for most noise measurement, no matter what it's for, is that for both handheld units, the sound level meter and the dosimeters, you should what's called field calibrate before and after you use it. And that's using that. So that little thing on the screen there, that little black tube, is a calibrator. And that basically gives a specific tone at 1,000 hertz at a specific decibel level that your equipment is expecting to receive. And your equipment will then check itself against that tone and adjust itself slightly so that it's super accurate. So plan to do this field calibration, I would say, before you start work with the equipment, and then maybe halfway through the day, and then definitely at the end after you've measured. So you don't need to do it after every measurement, but at least at the beginning and at the end. That way you can ensure that the equipment that you've used has been completely accurate throughout. So just a little tip there. Okay, there is software. I'm not going to go into this too much. Different equipment has different analysis software. If you're using a sound level meter and you just want to write down the numbers that you see on the screen for every location, great. Noise dosimeters, if you're just interested in the overall numbers, fine. But of course, you can look at the graph, as I've said, and we've got the software with our equipment called Noise Tools, which has got tons of useful information in there. It's got a hearing defender calculation part. It does reporting, etc., etc. So just have a look at the software. That may help you, particularly with your reporting. So this is Noise Tools. It's a database. Data can be shared between people, exported. Reports and graphs can be produced. You can calculate daily personal exposure through it. As I said, hearing protection selection. And we always make sure that the integrity of the original measurements are kept. So you cannot, once it's downloaded from the device, you cannot alter it in the database. It's fixed for all time. You can delete it, but you can't alter it. So it's just a useful way of handling your data. Not everybody does that, but I would recommend, if you've got this type of equipment, definitely download the data. Don't just write it down. Then you've got it forevermore, and you can always go back to it, and you can always do lots of interesting and whizzy stuff. I've just spotted a comment come through. The software is Windows 11 compliant. Yes, it is. The other thing that we were talking about today is this measurement aspect of things. Now, doing a noise assessment with the different types of equipment is great. You've just got to look at, maybe there are other options there. Some workplaces are really difficult in that the noise levels vary so much. So everybody's nice and happy, it's quiet, and then suddenly a machine starts up at the other end of the factory, and the noise levels shoot up, or maybe 2 or 3 machines start up. So sometimes it's not that clear cut. Are people okay? Are people not? It only happens at certain times of the day, etc. So where you've got noise levels that change over time, to do with some of these specifics that I've mentioned there, whether it's different workloads, different materials, whether they've got the radio on or not. I was thinking more of entertainment values, but actually turning the radio on usually has a big effect. Take this into account when you're doing your assessments. So you might need to sample over multiple days. If people are using tools a lot, make sure you have a good sample of people doing, and even if they're doing similar roles, they might be using different tools for different lengths of time, etc. Do that. There is a way of monitoring workspaces over longer periods of time, rather than just with a handheld sound meter or noise dosimeter. It doesn't supersede risk assessments, but it does give you an idea of what your workplace or what your workers are being exposed to, if you're not sure how that noise level is varying. And that is an example of a permanent monitor that you'd stick in your factory to measure just 24/7. So it could be just an addition to your noise at work risk assessment routine, just to make sure you've got a permanent idea. Are those noise levels starting to rise over time? So it's just another idea to supplement that. These are used quite a lot in the workplaces where they do have noise levels that vary, and they want to see how they can sort of minimize that variance over time. One other thing is sort of noise activated warning signs, which are things like this. Typically same colors and sort of layout as the normal sticky signs that you put on the doors, whether it says hearing protection zone, that sort of thing. These will light up when the noise level gets above a set level that you actually set. So these can be quite useful for areas that are not that noisy all of the time. So when they light up, people have to put the hearing protection on. When the lights go out, then they can take it off. So that's just another option you can think of if you've got this variable noise levels in your business, which can be really annoying, because you know that you don't want to expose people to too much, but really you don't want people wearing hearing protection when they don't want to. And that's one of the things about hearing protection, is getting that hearing protection level correct is really, really important, because if you get it wrong, and if you get it too light, so the hearing protection is too light for the noise, then obviously that could end up damaging the hearing over time, which is bad. But the other side of the coin is, if you have the hearing protection which is too strong, so you've just basically over-egged it, then people will feel isolated. There's more of a chance of them having an accident because they can't hear alarms, they can't hear the forklift truck behind them, they can't communicate properly to people, they're feeling isolated. What tends to happen is people just won't wear them in the right way. So you get the two-factor effect. The people that are wearing them are more at risk, not from noise, but from other factors. And the people that don't bother wearing them because they're just too much, too isolating, they don't wear them properly, so the noise gets in. So getting that hearing protection level right is a key thing. So just to conclude this little part of it, sound level meters versus dosimeters, it's places versus people. You may need both options. Every workplace is absolutely unique, but if you ever have to choose, focus on individual risk. But of course, the assessment is just the start. Okay, so just a quick bit on reporting, because I can see the time's marching on, and we've got quite a few questions, which is great. So any sort of report that you do, and you need to do a noise assessment report, it doesn't have to be huge, hundreds of pages. Keep it short and simple. But typical content of any report would start off with an action plan, right? So you need it's got to have this as an end result of it. You're doing a brief review of the risk areas and the different items of plant and people, etc., etc. You've got to fit in there somewhere, probably the appendices, the noise control results from all of your measurements. And then you're going to have some short-term and long-term recommendations, which are going to feed into that action plan. So short-term recommendation might be, we need to issue hearing protection at this level for this activity or for this area, something like that. And then longer-term recommendations would be more about how to, as I mentioned right at the beginning, how to reduce the noise levels at source. I've got a couple of examples coming up. You might want to put in a factory plan so people can sort of see color-coded where the risk areas are. And then in the appendices, as I've mentioned, you can put all of the details of the equipment that you mentioned, that you used, when it was calibrated, all of the detailed results of all of that. So all of that technical stuff can be in the appendices, but the key thing is to do something about it. There's no point doing a risk assessment and there's nothing comes of it. So that's one thing. And then you can actually review this on a regular basis. So I mentioned earlier, a little while earlier, just have a quick sip, this hierarchy of controls, just to give you an idea of how effective things are when you're trying to reduce the risk of noise to your employees. Now, this hierarchy of controls are used right across different health and safety areas, and it's very effective to look at this in terms of noise. So we know that that first level, the blue one, the elimination, if you physically remove that hazard completely, then that's the most effective way of protecting people from noise. So there's a machine that runs all day long. It's creating a lot of noise. It's very high noise levels. Do we need it? No. Turn it off. Get rid of it. Move it somewhere else, right? So it's eliminated from the equation. Does it have to be inside the factory? Could it be outside? That sort of thing. So physically removing it. Most effective way, you're getting rid of the noise. The next one down is substituting it with something that does a similar job but might be quieter. So you're replacing it with something else. It might be a different technique, a different machine, whatever. So you're replacing it with some other thing. That activity that's creating the noise may still be there, but we'll have reduced it by maybe buying a quieter machine or by doing something in a different way. So it's not quite as effective as the top one where you get rid of it completely, but it is more effective than the ones below it. The next one down is engineering controls. So this is where it's all about isolating those people from the hazard. So isolating people from the noise, or if you turn it around, it's isolating the noise from the people. So you could have a big compressor unit in the corner of a factory creating a lot of noise when it comes on. So you could box that in with some soundproofing, that sort of thing. So you're isolating the device from the people, and the amount of noise it's now producing is a lot less because you've done that. You could put in maybe some acoustic curtains. You could build a wall. You could move people around the factory from the noisy areas somewhere else. I've seen a factory where the packing area was right in amongst all of the really noisy machinery. That could have been moved 30, 40 meters down into the warehouse part where it's a lot quieter. So basically making people move and isolating people from that noise in whatever way, or the other way around. Not as effective maybe as a substitution or elimination, but still pretty good. Then we come down to the administrative controls way of doing it, and that's really about swapping people out. So don't have people in those noisy areas for the whole period. Swap people out, getting them to do different tasks, so they're not in there as long as they were before. So that's the way. So they're not exposed as much because you're reducing the amount of time to that exposure. And then finally, the least effective of all is relying solely on PPE, personal protective equipment. Now, the great thing about PPE for noise is if you specify the right level of hearing protection and it's in good condition and people wear it correctly, it works. 100% effective. But it only works if the people that are using it use it correctly, they maintain it, if they don't allow it to be worn or anything like that, they're wearing it in the correct way, and it's the right level in the first place that's been issued, the right level of hearing protection. So it's all about people. So the more you rely on people, the less effective any controls are. That's basically what this triangle is saying in all instances. So you're relying on people to look after themselves and to do the right thing, it becomes less effective. There's more managing involved. So therefore, when you look at it overall, it becomes less effective. And sometimes, and quite a lot of the time, you may be just relying on PPE because there's nothing else you can do. And what the health and safety executive and anybody looking at this will look at it and say, have you considered all of these other things to reduce the risk? And if you have, it's not practical, it's way too expensive, whatever it happens to be, you've made some strides, you've looked at it, that's what they're looking for. Have you made the effort? Have you made the right effort to do this, rather than just relying on PPE at the end of the day? And that's one of the key things about this hierarchy of controls. PPE works, which is great, but if it's done properly, and it is not an easy thing to manage, because we've all seen people walking around with hearing protection hanging out their ears and just not wearing it, or they've got some earmuffs and they're half on their ear and half off and all the rest of it. So and noise is like water, it gets in everywhere. So if you're not wearing your hearing protection correctly, it's as if you've not even bothered wearing it. The protection just drops like a stone. So it's very important to get that right. Some other suggestions, I'm just seeing where we are, excuse me 1 minute. Some other suggestions we've got here for just things you can do once you've done your noise assessment is things like labeling areas. So if you have a zone that you want to make a mandatory hearing protection zone, make sure it's labelled up and it's very clear and concise as to what that area is, to wear hearing protection in that location. That's very, very key to do that, and to make sure that you cover every entrance and exit and all the rest of it. You might go down the road of actually labeling tools. So it could be that everybody's fine, but until they start using a particular tool, whether it's a stationary tool like a tower drill, or it's a portable tool, whatever it happens to be, you could say, and put stickers nearby on the cupboards or wherever they're kept, use this tool, you wear hearing protection. That's another way of doing it. You have to be careful with that, because some tools can create such a loud sound around them that you may need to put a perimeter to say, well, anybody within, 10 meters of somebody using this particular tool will need to wear hearing protection. But if you're outside that zone, then you don't. Make sure that you do provide quiet areas for breaks, and the lengths of time for breaks and shifts are adhered to out of those noisy areas. It won't affect too much the overall score, the overall average noise level. It will have a little bit of an effect. So if the noise level is super high, remember, then just being in a quiet room with 60 to 70 decibels isn't going to really counteract that really loud noise level. But just give people a bit of a break from that constant noise, if nothing else. I've seen break rooms where they're just the same noise. You can see the factory, they're up on a mezzanine level, they're just being blasted with the same sounds that they've got all day long. It's not good. Make sure that you maintain equipment rather than just relying on things breaking and then repairing them, because a lot of what creates excess noise in a lot of places is equipment that's not running correctly, squeaky conveyors and all sorts of other things. So it's probably cheaper to maintain than repair, but it's also better for the amount of noise that's being put out. Make sure that you have some control techniques in place to make sure that things like the maintenance and repair and any other things you put in place to make sure that people are wary and notice those signage. It's all been reviewed on a regular basis. One of the things with the with doing a noise assessment is some people think, well, I'll do it and then I'll do it in 2 or 3 years' time and then I won't ever look at it in between. Having that regular review of noise levels in certain areas, the initial assessment will tell you where the issues are, but having that regular review of what you're doing is key to making sure you don't get any surprises further along the line. Always have a policy of buying the quieter tools and things to do this job, because all equipment that makes over about 70 decibels of noise has a very specific sound power level number on it in terms of decibels. That doesn't really tell you how much noise you're going to experience if you stood next to it, but it gives you an indication. It's not that, so you could compare the sound power level between two different pieces of equipment, and if they're both identical, why not go for the quieter one? And that's just going to reduce those noise levels. And again, make sure that the toolbox talks for staff are implemented and you're doing it on a regular basis. Because if you are relying on hearing protection, just ramming that message home on a regular basis will make sure that you're not walking around and finding people with things dangling out of their ears, because it's so easy to let that slip. So I'm sort of getting to the end now. There's last slide here. So basically, once you have the data, don't just rely on PPE. Make sure you've made, as I said earlier, as many strides as possible to reducing the noise at source if you find that you've got people at risk. Make sure you've looked at it, looked at all the options, and write down what you thought, what you can and you can't do, because that way, if the HSE comes calling, they can see that you've actually done the right thing and you've considered it. You may have to rely solely on PPE, but at least you've done that initial piece of work. But if you can't, make those efforts to reduce the noise levels at source. That's really, really key, because that is the most effective way of protecting your people. You may need to get some experts in if they're required. So you could, you might identify, for example, some sort of some fans or cooling fans or something, whatever, that's creating a loud sound in the factory. There are ways, there are companies out there that can help with all sorts of things like this. Whether it's the mounting of equipment or it's a lot of sound comes from obviously rotating machinery of some kind. There are quite a few really good companies out there that doesn't necessarily have to cost a fortune, that you can get in and do some work to reduce those noise levels at source. You would be surprised. So there's a lot more can be done these days, just with sort of additions and modifications and things like that to the equipment. So it's something to have a look at that. Make sure when you do make those changes, and you've made changes, then make sure you know what difference it's made. I've had people say to me, well, Craig, I've done all this work, I've spent like £10,000 and I've measured the noise levels and they're only 3 decibels lower. And then you might think, well, yeah, that's not much, is it? But actually it is, because what it means is that you've halved by reduce actually the amount of noise that you're exposing your people to in that area where you've made the change. You've halved it by reducing by 3 decibels. You've halved the amount of noise that people are exposed to. So make sure you measure again afterwards to make sure those changes that you've done have been effective or not. And don't be too disheartened if it's not dropped it by 20 decibels, because decibels are logarithmic. The more you can get, the bigger the impact is going to be. And this is not a one-time exercise, of course. So some people actually, are monitoring, not the full assessment of things like this, but they are monitoring on a regular basis. So you change the layout of a particular workshop, you may want to do some measurements again because the noise levels will have changed. You put a new piece of machinery in. What difference does that make? You're working on a new product line now, so it's a new raw material that might have different acoustic properties in terms of what noise it emanates when you're working on it. Maybe test that again. So it's just not a one-time exercise. So don't just leave it for every 2 or 3 years to look at it again. And then finally, and this is summarizing all of this up really, it's you will be able to protect your workers' health with targeted actions, and that's the key thing to take away from this today. So I've covered quite a lot of things today. In this talk, I've gone over the hour, so I wanted to leave a bit of time for questions. So noise monitoring in the workplace is a huge subject. There's a lot written out there. We have some online resources as well on our website. There's lots of other resources available. As I said, the control of noise at work regulations is really, really good. I would recommend at least you download a free PDF of that and have a look through it. That may help you. So thank you everybody for that. What I'm going to do, I'm going to whiz through and just go through some of the questions from the top. And let's have a look what we've got. So yeah, a copy of the presentation will be sent to everybody that's registered and obviously everybody that's been online. So you'll see a copy of this presentation, everybody. There's a credit for CPD and certificate will be issued. I'll check on that separately on that and let people know on that. Let's have a look. What else have we got? Right. Man keeps flipping back. People have mentioned the HSE website in a couple of things here. The HSE website is a great resource, not just for that document that I mentioned, but there's also a couple of spreadsheets in there which are really, really handy. So one of them is a one for calculating people's exposure for noise at work. And if you remember earlier when I mentioned that with the sound level meter, you're taking individual measurements. And it could be that what you do is use this HSE spreadsheet, and you can put in there all of the measurements that you've done. So this could be, say, 4 locations. So you put those numbers in, the LEQs, and then what you do is you say, well, how long is an individual typically working in location 1? Let's put in the length of time. How long for location 2? Put in the length of time, and then how long for location 3, etc. And then once you've done that, and that totals their work day, then you can click a button, and it will work out what their exposure is over a typical 8-hour working day, the LEPD. So it's great to do that. And then you can play what ifs. Well, maybe if he wasn't in there for quite so long, we'll just reduce the amount of time in that location and increase it in the other, and you can recalculate it. So it's really good. The other spreadsheet is for calculating hearing protection. Brilliant little spreadsheet. For those of you that want to know, there are 3 different methods of calculating it. I'm not going to go into it now, but there's 3 methods, getting increasingly more complicated, but that spreadsheet does it for you. And it tells you what numbers to put in, and then you can pick a hearing protection product, a level, and it will tell you whether that hearing protection product is good or bad, and just sort of color code it. So it's a really useful tool. Right, so a couple of comments that people have made. I think Michelle here, sort of replacement of high decibel tools should be a consideration as an effective measure for reducing noise exposure. Absolutely right. So I've seen quite a few companies who, instead of just following the people and measuring the people, have done an exercise measuring the typical decibel levels from the tools that they've got. A couple in this with hand-arm vibration as well, they do it at the same time. So you'd use it on typical materials, get an idea of how loud it is, and then you've gone through every tool in different possible scenarios, and then what you've done then is you've worked out which are the really bad ones, and then look at replacing them with something quieter. But also you can tell which ones are going to need hearing protection. Let's have another look. A couple of more questions. Lots of thumbs up, which is great. How would one measure the sound level of a fire alarm sounder? Should this be done during an evacuation drill, or is it a one-off reading at the location of the complaint sufficient? The way they test these fire alarms is a very specific way. There's a specific standard for testing them. It usually uses what's called a slow time constant, and they're typically measured I think at a certain distance, but you may want to, I've even done some work in fire stations before, where their sounder goes off because they're getting called out for a shout, and they needed to measure it in certain rooms. So you need to make sure you know what the noise level is in certain rooms, so everybody can actually hear that the sounder going off. But yeah, this typical equipment that you purchase here will usually is usually equipped to do fire alarm testing as well. Let's have a look. A bit about the vibration webinar, which is going to be one of the future ones. When you can't physically remove the noise, for example, on a construction site, how do you manage the hierarchy of control as multiple noisy activities are going on at the same time? Yes, difficult one. Dynamic work environments like a construction site are very, very difficult to manage there. If the noise levels are typically in whatever's going on is going to be really high, then maybe a generic sort of hearing protection would be good in that case, because you can't, you have to rely on hearing protection, basically, is what you're saying in that sense. It's always worth trying to understand what is the worst case. But obviously, because it's so dynamic, it's really it's really very difficult to do. So a lot of companies will insist on wearing hearing protection of a certain level that covers most eventualities. But as I say, you've got to be really careful with it, because if you over-egg that hearing protection, then that can create more danger. Another question: what is the maximum acceptable difference between the initial and final calibration? Basically, typically, if you put a calibrator on a machine and at the beginning of the shift, put it on of the work, put it on at the end of the work, and really, if the difference in what the meter's reading is more than half a decibel, I would say then you potentially have an issue with your equipment. It's always worth talking to the manufacturer about it if you do get that sort of difference. Okay. Natalia here: could noise levels greater than 90 decibels be recorded to verify that these noises are the same as the worker speaking too close to the microphone or a knock? Right. So there are, I see what you're saying there, Natalia. So if you're wearing a noise dosimeter and you hear a high noise, or it measures a high noise level, that could be to do with things tapping it. So typically with dosimeters, if you knock it, to be honest, that's really going to happen when you're at work and you're moving around. You get high noise levels, so associated with somebody knocking into or tapping that noise dosimeter that's on the shoulder. So what you can do is you can buy a noise dosimeter like one of our dose badges, the Dose Badge 5, which has a tamper detection in it. So the tamper detection knows that it's been knocked, and it marks up that particular high noise level as being a knock, a tamper, as we call it. So that's one way you can do it. You also mentioned, there are some dosimeters out there, not many, but you could actually record the audio, so you can listen to some of these high noise levels. That's sort of the direction it's going. So that's something else you could do. But generally, if you've got the tamper detection, that really covers most of what you need. Rachel, is there a dosimeter which can be used in ATEX areas? Yes, we have a dose badge on the presentation. You'll see a gold-coloured dose badge. That is ATEX approved right across the world. So that's fine. Actually, quite interesting. One thing you won't find, there's an ATEX approved sound level meter. So people tend to rely on the ATEX approved dosimeters. Getting sound level meters through ATEX approval, very expensive process. I think there was one a few years ago that was very basic meter. I don't believe there are any at the moment. So there are ways around it, but yeah, noise dosimeters is probably the way to go. question here about, should the noise level be 105 to 110 decibels for less than 5 minutes? Can this lead to permanent hearing loss or permanent ear damage? It all depends on your calculation, Mulk, because it's really all about understanding what the average level is over a typical working day of 8 hours. So if it's 105 to 110 for less than 5 minutes, what was the noise for the rest of the day like? And you can use various calculators to do this. So you could say noise level was, say, 110, 5 minutes, and the average for the rest of the day was sort of 80 for 7 hours and 55 minutes. Then it will calculate what that result is. In that case, I can't do it in my head, it's too complicated, but that'd probably be okay. But the longer you're in that higher level, the more impact it has on that average. Right, I'm just trying to have a look to see if there's anything else I may have missed. Some really good questions there, thank you very much. Right, I think people mentioned about the vibration webinar, which will be coming up, so which is really good. Do a similar thing to what we've done today. Right, I think I've just about covered everything that I can see. Thank you very much for your comments. I really appreciate your time. And if anybody's got any issues or any questions with what they've seen here, or would like any more information on our products, and if you've got any questions related to measurement or anything like that, please do get in touch. We've got a lot of experience here. We'll be able to help you. And unless anybody's got any final questions, then I'll just say thank you and for attending, and it's been really enjoyable. Thank you.